anytime you guys have questions, you just pop your hand up. We'll come up here once I start to scan. We're going to laser scan some stuff. Any questions, you got to just stop me. The other thing is some of the lingo that I use, I spit this stuff out all day long. In the world I run in, all these guys understand this terminology. So if I say anything, you guys are like, that made no sense to me. Just stop me, all right? Okay, I did want to show this little video. I just had a new promo video put out on my website. And I want to talk a little bit about that too. That might spark a little conversation going on, because there's just some crazy stuff that we did in this video. That's like, every day we do something that's crazy. You know, one of my guys will call me, he's like, I'm shooting this today. I think that's crazy. Let's do a video on it, or let's take a look at it.
Silly.
Yeah, so pop it open here. And the first part of this will kind of go through all of the equipment that we use. We did this at the airport in Holland with the big heroic music at the front end of it. All this stuff that we get into and all the equipment, I'll talk about each of them as we get into it a little bit. More of a demo for video, but we have scanned aircraft before, which is intense, it's crazy. And then each of these I'll talk about. This is the reverse engineering I'm going to get into today. And how we can make replicas from that. This guy gives us a statue. Look at this is crazy. We made a model of a statue in an old church museum. The sanctuary of a church. We've got big scanners for that. So if you want to replace seating or change walls or anything, we can develop a CAD model from a big stadium or a church. And I'm going to talk about this piece of equipment just a little bit. That's for big aircraft or military vehicles or bridges, big stuff. That's a laser as well. Some new product stuff. This is all a 2017 truck that we were scanning a new plane design for. Some tooling for a Corvette hood. Quite the software like we do. So we offer courses and training videos online too. Thanks, Mike. I wanted to talk a little bit about that guitar. This was crazy. This guitar that was at the front of that thing, that was from 1954, and I don't know guitars. Does anybody play guitar or anybody big into music history or a little bit? It's a Gibson Les Paul. So from 1954, this guy had this guitar, and it was broken. So he was going to rebuild it. So he finds us on the web, certain keywords. We pop right up on the search. So if any of you guys are ever getting into web development or anything like that, that's an amazing field as well. I pay my guy a lot of money monthly to have us exposed on the internet really well. So this guy finds us on the web. He takes us this guitar. He wouldn't even ship that guitar. He drove it from downtown New York. He drove that thing. Like, we'll just ship it or put it on the plane and fly over. He's like, no way. I'm going to rebuild this thing. I've got wood from the original plant, this Gibson guitar plant, and he was going to rebuild this guitar. It was amazing. So he came on in with a guy that was another guy he built a guitar for. And this guy just started, he was just playing music. He took another guitar, hand-built guitar, and he was playing music and just strumming around. And one of my technicians, he kind of looked at the guy playing guitar. He's like, are we in the presence of greatness? Should I know who you are? I mean, this guy was such a great guitarist. And he's like, no, he says, I just play guitar, and I fix him with this guy. But we scan this guy's guitar, and then mathematically in a CAD model, we can develop a cutter path for wood or a mold, like I'll show you what we're gonna do with this brain. So we can take geometry and turn it into tooling, okay? All right, let me just show a couple examples. Can I switch over?
Let me switch it over.
Yeah. All right, good, good. So I had a couple things I wanted to show you guys. Like here is one thing that was super crazy. So we'll get calls once in a while. This thing, a few years back, this company sells equipment to the military, and they wanted to know, what does this tank look like? This thing floats, it's crazy. This thing comes off a boat with 15 guys in it, and it floats, and it just goes like super fast on the water. As soon as it hits the beach, it takes off. So all this baffling here is supposed to make this thing invisible to somebody's radar. So if somebody's looking at this from their radar and they're looking out in the water, they won't see this device or this big tank. So what we did is we developed a model of this tank that looks like this. So this CAD model, they can put it into their software and they can look at it from different angles, different views, or distances and vectors. And they say, what does that thing look like on the water? You know? So that's what we do. The equipment's portable. We load it up, and then we just go capture this data and develop models. So we have had guys come into the lab, though. There's a company here in Zeeland that will make training devices for med students. And that's what I wanted to talk more about with you guys, is this, this laser scan. So he'll take us some vertebrae, and then we'll mathematically build them into a spine. And then what they can do is make injection molds, so they can make 1 million of these things. So people aren't cutting on cadavers. They're actually doing mock surgeries with, oh, I didn't put that in there. I thought I'd save Lene, because I have a picture. We scanned a, we call it a buck, but it's a butt, right? Non-gender specific, but there was a person we had to scan from here to here, because during back surgery, and I didn't know this, they take a person and they lay them down, instead of on their back or on their stomach, they lay them on their side, and they put a wedge underneath here, and they put an incision here, and they work through there to do your spinal whatever. I don't know what they do, but we scan this on somebody and that vertebrae, and mathematically we can put them in the same space. So they can have a tool or mold that can make these as well as this. So it's crazy. I mean, who would have thought you can capture data, reverse engineer it, instead of having so many cadavers or other devices that don't quite mimic a brain. You know, you carve that by hand maybe and make something close. This was an actual brain at one point. This was this company in Zeeland again, they took a brain and made we call it a silicone pore. Bear with me on this. This is what they do, is they'll take this box, they'll suspend a brain or an artery or some organ inside of this box, and then they pour a silicone around it. Then after a while, that silicone sets up. So they can pull this out, and now you've got a cavity here that they could pour epoxy or pour a material into that takes this shape. Then we can scan this to turn this into a steel mold, okay? Does that make sense with anybody yet? Any questions on that? Okay. We did have, this was fun too, a guy a couple years back from Grand Haven makes longboards. Smokin' Mad Love is the name of his company. He found us too, and he had a hand-carved longboard out of plywood, and it was formed, it was beautiful. And he says, I would like to reverse engineer this and make a tool so I can make 1 million of these boards. So we scanned that guy's tool, or that board, and I told him the first 7 that you get off that tool, I want them. So we took that board, the first 7, we put our logo on it, beautiful trucks made out of Muskegon, and I gave it to each of my guys, so, and my nephews too. But fun, just to be able to capture that data with something like this. But what I do want to show you guys, just a couple things. So, remember I showed you that church? This device does big scanning. It's not very accurate. So if you think about a millimeter, and we'll talk amounts here in a little bit, but this is accurate within 1 millimeter. In our world of inspection and laser scanning like this, 1 millimeter is a mile. It's crazy how big and how inaccurate that is. But when you're reverse engineering this historical home, this is a point cloud, we'll talk about this in a minute, but say if this house was ever to get destroyed or vandalized or something happened in a fire or something, we can recreate this building within a millimeter of what its original, all the woodwork, everything, we've got captured digitally. Okay, so we've captured and reverse engineered all that data with a point cloud, we call it. All right, what else was I gonna quick show? Oh, one other thing here. So this device I was gonna talk about just for a second. So this, it doesn't scan with a laser, but it measures with one beam at a time. So right now we're measuring this turret, and I've got a couple of these other ferro arms like this here, and they're all talking to the same piece of software. So from there, this company wanted to protect soldiers as they poke their heads out of here and here. They wouldn't tell us quite what their device was to protect these guys, but they said capture the geometry, every inch of this turret, and develop us a model. So that's what we did. We just took a bunch of these devices and that laser tracker, and we made this. So very fun stuff. Okay, I'm gonna just, for a second, just talk about accuracy, because that's one thing. Is there a pen I can?
Yes, I got them buried.
Okay. Don't give me the permanent marker.
No, it's happened.
Okay. So you guys have all been through, like in, I think, middle school, don't you guys? Yeah, Gunnar.
How long does it take you to like do a full scan for like different, like obviously like a house would take longer than like that turret, but like on average, how long would it take?
It's so diverse, man. It's crazy. So we've done little printer parts or little medical devices. They'll take maybe 5 minutes. The house, that big house, we did the inside of that thing too, so that was a week. That was, every place we'd go, we'd set that scanner up and just shoot. So that took about a week. The turret, for us to do the data capture was 1 day. The CAD guy took about a week to do the CAD model. So he takes our data yet and massages it, makes it into, we call it a toolable model. So that's the thing too. Like if you guys ever get into, I think metals and woods, don't you guys go through SolidWorks? Has anybody taken that with Musin or with Crinion?
No. I'm in drafting.
Okay, so you guys are in AutoCAD now then, right?
Yeah.
Okay, good. Architectural stuff is very AutoCAD based. The turret, the brain, all those kind of things that are product focused are very SolidWorks or CATIA or Pro-E based. I thought you guys learned SolidWorks here too. Doesn't Crinion teach that?
Yeah.
Is it a senior class?
He does manufacturing.
Okay.
You do a lot of stuff with that.
Man, I kid you not, that is such a field that is worth its weight in gold. Every machine shop we get into, so we'll do scanning and inspection for these guys, and every place is cranking busy. Every place. And they're saying, we can't get enough guys that can program that machine to cut steel. That's a big program at Ferris for undergrad, is a manufacturing engineering curriculum that has machine tool in it. They can't get guys to do it. It's crazy. And that place, every machine shop we get into, every one of them is looking for people. It's crazy how cool it is. How you doing, man?
Good. How are you?
Sprain or?
I think it's just bruised.
Oh, don't put any weight on it. I can bring it home though if you want after we're done.
I think I'm gonna stick it out. But
Good for you. All right. Well, I'm glad you made it in.
Yeah,
That's very
me
good.
too.
Okay. So I did want to talk just a second about accuracy because you guys have been through, like on a graph, you get your X and your Y, right? And you can plot curves and plot lines, all this cool stuff. Well, when we scan, we introduce the Z into that, right? So I've got a Z coordinate. Have you guys done Cartesian coordinate systems? I would think by now you've talked Cartesian, haven't you? Yeah. In trig, I think, or is it geometry you're taking that?
No, I don't really know what that meant yet.
What? No, she's give me the head nod. Cartesian coordinate system,
meant
X, Y, Z.
Okay.
Okay.
You mean three-dimensional?
Correct. Yeah. Yep. Yeah. Because I know you've done an X and a Y. All you guys have done this kind of a deal, right? Where you do an X and a Y, and we're introducing the Z into that. But what I wanted to talk about though a little bit, so when we talk about inches, so if 1 inch to you guys looks something like this, the accuracy of this equipment, 1 inch to me is out here in the 10,000th decimal. So this equipment, well, let me tell you this. Okay, so a human hair, if you pluck a hair or if you look at a sheet of paper, that thickness is 3/1000ths of an inch. That's typical hair or paper. this equipment is so accurate, it knows if you took a hair and you divided it into 6 equal sections, this thing's so accurate, it would know which one you gave me. If I was to scan them, it's, oh,